Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Welcome back, grade 9 learners. Welcome to today's natural sciences lesson. My name is Mr. Stianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, we are still exploring what planet Earth and beyond for our term 4, right? And I said today's topic is the birth, life, and death of stars. And we'll be specifically looking at the birth of a star, right? So now, yes, we had some technical glitches, right? And apologies for that. Now I hope you can hear me perfectly. Now let's continue. Our lesson objectives, right? What we need to achieve by the end of this lesson. So the first one there is what? Is to be able to explain that stars exist for a finite period of time. And you need to be in a position where you are able to explain that stars form inside huge clouds of gas and dust called what? Nebulae, right? And that they are far out in space. You should also be able to explain that these nebulae are pulled together by the force of gravity and slowly collapse as they contract. And as they contract, they heat up. You should be in a position also to be able to explain that once the temperature is high enough, the nuclear fusion reaction begins, right? And the nuclear fusion reaction changes hydrogen to helium. And also, you need to be able to explain that the nuclear fusion reaction radiates large amounts of energy into space. And all this information is found under the CAPS document on page 83. Right, moving on now to what we have done in the previous grades and the same grade which lays foundation for today's topic, right? So in grade 7, we introduced what? The periodic table. So we discussed the introduction to the periodic table, right? Saying that the periodic table consists of all elements, all known elements, which are about 118, right? And we said that there's more room for discovery as well, right? It is not limited to that 118 elements. Also, in grade 8, right, we talked of atoms. We said that atoms are building blocks of everything and anything that occupies space and has mass, right, which is matter. And atoms, we said that they have subatomic particles such as the positively charged protons, negatively charged electrons, and neutrally charged neutrons. Then we also talked about the relationship between the Earth and other planets in our solar system, right? We said that Earth is number 3 from the planets, is number 3 from the Sun, right? And we have 8 planets in total. And we also talked about in the same grade, which is grade 9, compounds, right? Which are 2 or more atoms that are different from each other, chemically bonded in a fixed ratio, right? That's what we talked about in the previous grades and the same grade, which lays a foundation for today's topic, right? So now moving on, let's look at this baseline activity, right? I want us to take some time to write down this baseline activity. I will give you 5 minutes to write down the answers, but firstly, let's go through the questions together. Number 1 is saying define greenhouse effect, right? Then number 2, it needs a whole explanation, right? It says explain how the greenhouse effect occurs, right? So let's meet again after 5 minutes. Welcome back, grade 9s. Now, I hope you had enough time to write down the answers, right? But now, remember our WhatsApp interactive number for further communication, right? Whether you want us to, whether you want to send in your answers or you have any comments regarding this lesson, right? Remember, it is 079 578 2908. So now let's mark this work. Number one, it's saying define greenhouse effect. Remember that this is the part that we were doing in the previous lesson, right? We talked of greenhouse gases and greenhouse effect. So it should be easy to answer this one, right? Define greenhouse effect. And we define greenhouse effect as a warming effect caused by the trapping of energy in the atmosphere, right? Then you mark your work. Number two, explain how the greenhouse effect occurs, right? This is how the energy from the sun or the insolation, right? Energy from the sun passes through the atmosphere and warms the surface of the earth, right? And that's not all. What happens? The warmed earth radiates the energy back into the atmosphere, and as well as the greenhouse gases in the atmosphere, they absorb or trap most of this energy, right? Warming the atmosphere closest to the Earth's surface. And also, just a reminder, right? Without the greenhouse gases, most of the energy would pass out to space and the atmosphere would be much colder, right? So now let's just take 2 minutes quickly to copy down the corrections. Welcome back again, grade 9s. Let's move on together, right? So terminology, these are the important terms that have to do with this lesson, right? The first one that we have there is a star, right? What is a star? We define a star as a shiny point in the night sky, right? A shiny point in the night sky, and it is also a ball of burning gas in the universe. The second that we have there is stellar evolution. Stellar evolution is simply the birth, the life, and death of stars, right? This is the life cycle of stars, right? The birth, the life, and the death of stars. That is stellar evolution. We then have gravitational contraction, which is the process whereby a nebula's gravity overcomes its internal pressure, causing a collapse. We then have what? Nuclear fusion. And we define nuclear fusion as the process in which atoms combine to create larger atoms and massive amounts of energy. Are we together, grade 9s? Now moving on, right? Stars, right? We're talking about the birth of a star today. But first of all, as we said that a star is a shiny point in the night sky and is also a ball of burning gas in the universe, right? So now looking at this picture here, right? We are able to identify this shiny point in the night sky, of which it is a star, right? As we can see here, there are countless stars, right? They are shiny points in the night sky, and also they are a ball of burning gas in the universe, right? They provide heat and light as well, right? So now, it is that shiny point in the night sky, as you can see from this picture. Now, stellar evolution. We said that stellar evolution is the birth, the life, and also the death of stars, right? So it means what? Stars exist for a finite period of time. What do we mean? When we say a finite period of time, we mean that stars are living for a certain period of time or to a certain extent. Are we together? They are born, they live, and they die, just like us as human beings, right? We are born, we live, and we die, right? So now, stars are also the same. They live for a finite period of time. They are born, they live, and also they die out. So stellar evolution is the process by which a star undergoes a sequence of radical changes during its lifetime. So now, just as us as human beings as well, right? You undergo certain changes in your lifetime. You are born, you live, you become a toddler, you become a teenager, undergoing a series of changes, right? That's what happens with a star as well, right? Or stellar evolution, which is the process by which a star undergoes a sequence of radical changes during its lifetime, during its life as well, right? So now, depending on the mass of the star, this lifetime ranges from a million years for the longest stars and also to trillions of years for the smallest stars. Now, what is a nebula in this case, right? How can we define nebula? So we defined nebula as what? As a thinly spread cloud of interstellar gas and dust. So it is that collection of what? Of gas particles and also dust where in the universe, and we call it a nebula. This is where stars are born or formed. They are born from a nebula, which is that thinly spread cloud of a collection of gas particles and dust. Are we together? So some nebulae are the remains of a supernova explosion, right? Which is a colossal explosion of a star, right? So many stars are able to give birth to other stars, right? And this results from what? A supernova explosion, which is a colossal explosion of a star and gives rise to what? To nebulas. Are we together? And also, the death and collapse of a massive star can cause this supernova explosion that I'm talking about. So this means what? Nebulae can be the remains of old and dead stars. And I'm saying that in a nebulae, this is where we find what? The birth of a star, or this is where stars are formed, in that collection of dust and gas particles. So now, most nebulae are gravity-induced, right? They are gravity-induced condensations of gases where protostars are born. Now listen to this, right? From that supernova explosion, you find what? Remains of dead stars as nebula, right? Or nebulae in plural, right? So what happens? That nebula is the collection of gas particles and dust. And within that nebula, because it is bound by gravity, right? Or it is gravity induced, what is going to happen? We're going to give birth what? Or going to give rise to a protostar before you have an actual star. So we can say that from this nebula, this is where the beginning of the birth of a star is, right? So for example, here is a NASA image of a nebula, right? This collection of what? Of gas particles and also dust, right? It is a thinly spread cloud, right? consisting of many gas particles and also dust, in which where a star is going to be born. So now let's just test ourselves quickly, right? With activity 1. So number 1 is saying explain what stellar evolution is and why it is a finite process. Number 2, it says write down the definitions for the following terms: A star, B, stellar formation, then C, a nebula. So take 5 minutes of your time and complete this activity. Welcome back, grade 9s. We are still waiting for those questions or any comments on our WhatsApp number on the screen, right? So now let's look at the solutions. Number one is saying explain what stellar evolution is and why is it a finite process. Number two, write down the definitions for the following terms, right? A, star; B, stellar formation; and C, a nebula, right? So the solutions for number one and A, stellar is what? The stellar evolution is the birth, life, and death of stars, right? So why is it a finite process? It is the process whereby a star will undergo a sequence of radical changes during its lifetime, right? So depending on the mass of the star, this lifetime ranges from a few millions for the largest and also trillions of years for the smallest stars. So stars need fuel for stellar evolution, but they only have a limited amount, so will run out, right? That's why we say it is what? A finite process. So now, because we need to skip to number two, let's just take a quick minute to copy down number one. Welcome back again, right? Let's look at number two, right? So now, for number two, the first one there we had star, right? And we said star is a massive luminous sphere of plasma held together by gravity far out in space, right? Or it is that shiny point in the night sky, right? Or a ball of burning gas in the sky. Also, we have stellar formation, which is the process whereby dense regions within molecular clouds in interstellar space, known as nebulae, collapse into spheres of plasma to form stars. Then we have nebula, right, which is a giant interstellar cloud of gas and dust, right? So the fuels or gases of a nebula are mostly hydrogen and helium, as well as smaller amounts of what? Carbon, nitrogen, and oxygen, right? So let's just take 2 minutes quickly to copy down these corrections, then we move on with our lesson. Welcome back again, grade 9s. Now let's move on together with our lesson, right? So now, gravity and contraction, how does it enter in this lesson, right? Remember we said that the nebula is governed by the force of pulling, the pulling force, which is gravity, right? So part of the nebula starts to shrink now. It starts to shrink and collapse under the pull of its own gravity, forming what? A protostar. Remember, the nebula is that the group of what? Of gas particles, right? And dust. That collection of gas particles and dust. So as it is governed by gravity, it starts to shrink and collapse under its own pull of gravity, right? To form a protostar. So this is a picture of what? Of the nebula contracting and also shrinking, collapsing under its own pull of gravity. As well as the protostar now begins to shape up, right? So now, as the nebula starts to shrink and collapse, it forms a protostar, right? And the protostar now begins to shape up during its gravitational contraction and it heats up, right? So its gravitational potential energy is then converted to kinetic energy, right? Kinetic energy of individual gas particles falling inward, right? So now, this is the formation of the protostar and heating up, right? Forming what? Kinetic energy, which is movement energy. Are we together? So now, what happens now? Those gas particles, they start to crash into one another, right? As they crash into one another, they are moving in that kinetic energy, right? As they are moving, they convert this kinetic energy to thermal energy, which is heat energy, right? So this is a diagram of gas particles clashing each other, right? Or crashing into one another. This is what happens, right? As you can see, they are moving up and down, crashing into one another, creating what? Creating thermal energy, right? Converting the kinetic energy they have into thermal energy. And as they do that, temperatures continue to rise, right? Temperatures will continue to rise up until nuclear fusion begins, right? Up until nuclear fusion begins. So now, what is this nuclear fusion that we are talking about here? Remember that nuclear fusion is the splitting, it's not the splitting, it's the fusing of what? 4 hydrogen atoms to form what? Helium. So the nuclear fusion reaction changes hydrogen to helium. Are we together? So in order for nuclear fusion to take place, there must be tremendous amounts of pressure and heat, right? So there's a lot of what? Gas particles moving up and down, crashing or crashing into one another, creating tremendous amounts of pressure and heat as the energy is converted from kinetic energy to thermal energy, right? And now, this pressure crushes the elements together to create larger elements and more energy, right? So the element that begins fusing first is hydrogen because it is the least dense and the easiest to fuse. So here's an illustration of this nuclear fusion I'm talking about, right? So you have two atoms coming together, right? These atoms, they fuse together to bring about this helium atom, right? These hydrogen atoms, they fuse together and they bring about what? This helium atom during what? Nuclear fusion, leaving there some of the neutrons out and releasing what? Energy, right? So now, remember that 4 hydrogen nuclei will fuse together to form one nucleus of helium, right? And the nuclear fusion reaction radiates large amounts of energy into space in the form of heat and light. So as we receive this heat and light, as a result, as you can see here, we start seeing what? We start seeing stars. So now, let's take it back a bit, right? We said that from a supernova explosion, we have leftovers of what? Of dead stars and forming what? They are forming nebula, which is a thin cloud of gas particles and dust, where a star is going to be formed, right? So as the nebula undergoes what? The contraction of its own gravity. What happens? It's going to form a protostar. and the protostar is going to convert that energy and the gas particles as well to nuclear fusion, right? And take it to nuclear fusion, we're going to have these two atoms or four atoms of hydrogen clashing into one another and forming what? Helium. And as a result, they produce heat and light. That is a star being born, right? So now, let's look at the sun as a star or as an example of a star, right? So the sun is a medium-sized star, right? It is made up of these gases. It is made up of hydrogen, helium, carbon, nitrogen, and oxygen, right? It is a medium-sized star. And the sun's energy spreads out into the solar system in the form of heat and light, just as stars, right? So this is an example of a sun, right? As you can see, right, it is producing what? Heat and light, right? This is because of what? Nuclear fusion taking place at the core of the sun, right? The hydrogen gases fusing with each other to form what? To form helium gas. So it goes in this formula, right? You have hydrogen atoms fusing together to form the product, which is helium and energy, right? So we said that this nuclear fusion happens at the core of the sun. That's why it is able to emit what? So much energy, heat, and light for all day long, right? So now, looking at the sun as well, it has different parts, right? Like the corona, the chromosphere, the photosphere, the inner core where nuclear fusion takes place, the radiative zone, and the convection zone. Now, what are some of the other examples of stars, right? These are the some examples of stars as well, right? The Polaris. We also have what? The Sirius star. And also we have what? We have the Alpha Centauri star, which we learned more about them in grade 8, right? As you can see here, they are shiny points where in the night sky, and they are what? Balls of burning gas in the sky. So now, activity 2, right? It says explain how a star is born, right? For 6 marks, because there's a lot to say, right? So explain how a star is born. So let's take 5 minutes just to write down this activity. Welcome back again, grade 9s. Remember that you are still waiting for those questions or any comments regarding this lesson, right? On 079 578 2908. Now let's look at the solutions, right? Explain how a star is born. Firstly, a star is born in a huge cloud of gas and dust known as a nebula, right? Nebula standing for a single nebula, right? Now, also, after that, the part of the nebula begins to shrink under the pull of its own gravity, right? Don't forget to mark your work as we continue. So this forms what? A protostar, and the temperature inside continues to rise. And also, as the protostar contracts, pressure and heat build up until nuclear fusion takes place at the core. So the nuclear fusion reaction changes hydrogen to helium, as we have said, right? And also, the pressure from inside the star finally equalizes the gravity pushing in, and the star stops contracting, right? And lastly, the nuclear fusion reaction radiates large amounts of energy into space, right? So now, let's just take a quick 2 minutes to copy down the corrections. Welcome back again, grade 9s. Now let's move on, right? Now we have a WhatsApp slide, right? So now this is a chance for you to write in those questions or any comments that you might have regarding this lesson, right? So let's just give you a quick 3 minutes to answer any question or to comment, right? Now, it seems like we do not have any questions or comments regarding this lesson, right? So now, let's summarize what we have learned for today. So today we're talking about the birth of a star, right? And we said that stars exist for a finite period of time, meaning they are born, they live, and they die. They only live for a certain extent or for a certain period, right? And we said that stellar evolution is the process by which a star undergoes a sequence of radical changes during its lifetime. And we said that a nebula is where stars are formed or born, right? A nebula can be defined as a thinly spread what? Cloud of interstellar gas and dust, right? That collection of gas particles and dust. And we also talked about what a star is born in a huge cloud of gas and dust known as a nebula, as I've said now. And part of the nebula begins to shrink under the pull of its own gravity, right? And this forms a protostar as a result. And as the protostar is formed, the temperature inside continues to rise, right? So as the protostar also contracts, pressure and heat build up until nuclear fusion takes place at the core, right? And remember that the nuclear fusion reaction changes hydrogen to helium. So the pressure from inside the star finally equalizes the gravity pushing in and the star stops contracting. And we talked of what? The nuclear fusion reaction radiates large amounts of energy into space. So now, we also have a homework activity for today, right? So let's take 4 minutes to copy down this homework activity. Welcome back again, right? And I hope you had enough time to copy down your homework. So now, in the next lesson, we'll be talking about the life and death of a star. So as usual, go home, open your textbook, read more about this topic so that when I come back again, it is easier to understand, right? From me to you now, thank you and goodbye.